Okay, one thing you may wish is that mathematicians could just agree whether they would use degrees or radians, and not just both, because that's twice as much stuff to memorize, right? Well, unfortunately, there are some applications which are just better with degrees, and some applications are just better with radians. When you get to calculus, you'll be using radians all the time. No one uses degrees in calculus. But if you're in some kind of geometry, you probably want to work with degrees and not radians. And the reasons will become clear when you get to those subjects. I don't want to go into those now. What I want to do is make sure everyone knows how to convert easily from degrees to radians and vice versa. So I'm not going to go through all these examples, maybe just a couple. Let's take 930 degrees. Okay, I'm going to look at this guy. 930 degrees. What is that in terms of radians? Well, I don't have that memorized. Maybe you have a couple easy ones memorized, like you might know that 180 degrees is always pi, and 360 is always 2 pi. But I don't know what 930 is. So what we're going to do is multiply this by a special fraction, pi over 180 degrees. And that is going to convert it into radians. So let's see what we get here. This is 930 over 180 pi. Okay, there's my fraction. Now, if you enter that, it's going to be wrong because pay attention to what this wants. This wants simplified fractions. So in this particular problem, yes, you do have to go through the work of simplifying. So I know I can divide each side by 10, or top and bottom by 10, make this 93 over 18. And I'm looking at 93. I know 93 is divisible by 3 because 9 plus 3 is divisible by 3. That means the whole thing is. So let me just pull out my calculator here. Divide 93. Oh, I know what that is. 93 over 3. That's 31. I don't need a calculator for that. 18 divided by 3 is 6. So I have 31 pi over 6. And that cannot be reduced any further. So this is 31 pi over 6. That's how I would enter the answer here. Okay? Let's try another one. Let's do, I'm not going to go through all these, but let's do negative 2 pi divided by 9. Now, you may be looking at this like, what is a negative angle even mean? I mean, it's not a triangle. Obviously, you can't have a negative angle in a triangle. Well, this is useful in mathematics, even if it's not always useful in geometry. There are negative angles out there. It just depends what your reference point is. And, okay, that's, not really important. Let's just apply the same technique that we would to any angle that we're converting into degrees. You multiply it by 180 degrees divided by pi. Notice this is just the first one flipped over, right? Because I'm converting in the opposite direction. Instead of degrees to radians, I'm going radians to degrees, which means this fraction gets flipped over on its head. Well, what is this? This is negative 2 times 180. That's negative 360 degrees. Pi divided by 9 pi. Okay, so your pi's cross out. That's nice. 360 divided by 9. I feel like I know what that is. Oh, that's 40. Okay, so this is 40 degrees. That would be your answer for this one. Okay.